Hello everyone and welcome to another video. Today the topic is climate change. I wanted to share a proposal I made last year given contest of sorts that was made out. You can see here in this Twitter page by Chamath Palihapitia, hope I pronounced that correctly. He's basically, from what I could gather, some sort of wealthy person from Silicon Valley that made out a call requesting ideas about solving climate change, decarbonization, etc. Specifically, he said he wanted to allocate a few $1 billion into these areas over the next couple of years. So, in this thread, he talks about what you should talk about in your proposal, things like that, and to submit all your proposal by the 31st of July of 2020, which is what I did. So here you can see my proposal. I don't think I got it, so that's why I'm making this video, just because, I don't know, it might give someone any ideas on things to do. I'm not saying I know how to solve climate change. These were just some ideas I came up with. But let's see a bit more in detail what I was thinking and how I was thinking and why I was thinking it. So my framework was basically resting on three main pillars, which is we should extract less fossil fuels. If we have to extract fossil fuels, we should burn them less or actually prevent their combustion in the first place. And then if we have to, or after we have to burn those fossil fuels, if we cannot avoid burning them, we should recapture that emitted CO2. And basically, I have here a bit of a criticism, which is that I made this proposal mostly focused on private enterprise because in terms of government action, I mentioned here that the IPCC was established in 1988, and still we have made very few advances in actually tackling climate change. So by basing it on private enterprise, I'm looking at trying to have positive incentives and feedback loops, which could make some sort of decisive transition, especially economically, which accelerates the adoption of certain ideas mentioned here. And also ecologically then through the positive externality that is decarbonization. So the first one is extracting less fossil fuels. And here I will be talking about some things I've mentioned in other videos, especially the innovation one. But basically, I'm assuming here that there will be either a continued energy demand or maybe even a future increase in demand. So we'll still be using energy and even more energy. So either we reduce the demand of fossil fuels specifically as the energy source and transition then to an overall energy demand to use a renewable source. And here I'm mentioning specifically that already we are seeing an exponential decline in the cost curve of certain key technologies such as photovoltaic, solar panels, and battery storage. And this must continue to accelerate its decline so that people switch from fossil fuels, which will then become more expensive than these alternatives. This is what I mentioned as the carrot incentive. At the same time, there should be some additional regulatory cost. This is a stick. But then again, this is relying on governments, which I don't go so much in detail in this proposal. So this means that if here I am making the argument that if you invest in making these technologies cheaper, solar panels and battery storage, eventually people will just switch to them because it's just cheaper. And I also talk here about biomanufacturing components and materials, that is, using natural or engineered biological systems such as microorganisms and cell cultures to produce biomaterials at an industrial scale. This is here to try to compensate the fact that even if we switch to renewables, they're still quite reliant on mining and rare metals, rare components that have all of these negative environmental impacts. So if we can figure out a way to both make renewable energies cheaper Plus, we use them of materials that are more renewable in the sense that you don't need to extract rare materials from the earth. We can just manufacture them from living materials in a way. That will be most ideal. That's basically the argument here. So even though this is futuristic, I think that developing organic electronics, organic logic gates, organic electric appliances, this would further reduce the dependency on mining and minerals and rare earth metals. And as it stands today, renewables such as solar and wind are poised to disrupt the entire infrastructure of oil, natural gas, coal, and nuclear fission. This is mentioning the work of Tony Seba, which I've mentioned in this channel before. Here I mention also that nuclear fission should be accelerated so as to drop its total life cycle cost. So here I mean specifically reducing how much it costs to build, perhaps via modular implementation, prefabrication of components, while keeping or increasing its safety aspects. And also exploring waste mitigation strategies, which is the big issue with nuclear fission. I do mention the possibility that cold nuclear fusion could come, but it's so complex and the research has taken so much time to get where it is right now that I think it might be unlikely that we come up with it in the time frame that we need to. I mentioned also in the terms of transportation that already seems like the electrification of passenger and company fleet vehicles seems a foregone conclusion because of increasing adoption across many countries. So therefore, ocean, ship, and aviation seem the last two major uses of fossil fuel for transportation. So unless we actually develop such a big increase in efficiency of battery technology, it might be likely that we could maybe use hydrogen fuel instead. And in some very specific cases, some sort of novel sailing technology. This is more for ships. So in this sense, in this proposal, I would therefore propose to allocate money, investment, research time in both hydrogen and sailing technologies applied to this long-distance ocean and air travel. Finally, I go into agriculture. So I think there should be like a two-stage transition. The first one would be to move plant-based production in cities or closer, either via vertical farms, which can be above ground in normal buildings that we have now, or below ground. And here I mentioned specifically using organic hydroponics. So this is where the nutrient source that feeds the plants, first of all, you don't have soil, so you can have much more cheaper and lighter construction. But then the nutrient source comes from food waste or even human waste. And this is to replace, again, this dependency we have on mining for the nutrient source that is common in conventional hydroponics. And the other transition would be also to do precision fermentation proteins. That's also mentioned in the work of Tony Seba, and insect proteins. And this would be an alternative to livestock proteins. This is still on the first stage of the transition for agriculture, I would say. So the idea is that you can, by investing in these, not only you reduce the cost in terms of transportation of the food and the production of the food, but you also keep the shape, the flavor, the nutritional content, although there is still that yuck factor in some cases, which might be, for example, with insects. So the second stage is then to transition to cell culture for both meat and plants. And all of these things are ongoing right now, but what I'm proposing is that the person that is interested in this allocate more money to research these things, to bring them faster to the market, to really create these new products that we are needing to transition. But anyway, cell culture basically is where you take parts of an existing animal and then you grow it in the lab. And here I'm including both plants and animals. Of course, animals is much more attractive because animals take so much time to grow and you have to feed them so much and they use so much space. I only when I think we have been able to optimize that will it make maybe sense to do that for plants. Because right now for plants you still grow the plant, but it's only really the leaves or the fruit of the plant that you eat. In reality, if you could just grow the leaves directly or the fruit directly without needing the plant to grow its stem, its flowers, its roots, you would also skip time and resources in that sense. So you would be more efficient in creating this food that we need to eat. But in any case, in both stages, we would, if we were able to do this, we would save so much from water usage, land requirements, transportation, and of course, fossil fuel emissions, which affect everything else. So on to my second part of the proposal, I here talk about how if we have to extract fossil fuels because we need to use them in some way, let's try not to burn them. Because it's not so much that when we take the fossil fuels out of the earth into the surface that causes the problem. It's only when we burn them that that goes into the atmosphere and has a greenhouse effect. So here, this is an important part. Fossil fuels are mainly condensed energy in the form of hydrocarbons. And that dense energy is stored as chemical energy in those carbon and hydrogen chains. And so that is released when exposed to small amounts of energy and oxygen. So combustion, that's when you burn things. Energy is the ability to do work, but that energy also grants long-lasting properties to a material in the face of entropy. So it is no accident that petrochemical polymers such as plastics are able to last so long on the earth before being degraded. It's precisely the awesome energy density of the original fossil fuel that grants them that durability. So you can see where this is going now. Therefore, a good way to ensure that we burn less of these fossil fuels that we extract is to find more application for them that result in more valuable byproducts than their original use as just an energy source that we burn away. So if a business can figure out a way to convert a fossil fuel into a byproduct that adds significant value, then the incentive will shift from the combustion to processing of those fossil fuels, which will prevent the combustion and therefore the release of the gases to the atmosphere. So as mentioned, fossil fuels made of hydrocarbons are energy dense and long-lasting durable. There are a few applications where we value such properties, and these include building materials, to construct buildings housing people and services that can withstand weathering events, biological degradation, and the effects of time. Data storage, to store valuable data such as personal information, media entertainment, historical archives, scientific results, and accounting and public records. Sensitive and valuable information in a format or a holder that can withstand natural accidents and the effects of time would be valuable for long-term storage and retrieval of the information within. And finally, energy storage, the ability to charge and discharge a medium capable of holding a high density of energy. Fossil fuels are currently the most energy dense and convenient medium we know of. I add here convenient, of course, because things like uranium are much more energy dense, but they're not as convenient to handle. So in this, I would say in this part of my proposal, it's the more speculative part. This is where I don't know of any real examples that some things might be possible, but I'm just thinking in terms of first principles that maybe could be good to research this. So here I talk about that we should not just consider plastics and specifically mitigating the downside of the flammability of fossil fuels. We could develop vastly more valuable uses of fossil fuels than their combustion. So for example, and here I'm really just speculating, if it would possible to use a battery that has quick charge and discharge but uses liquid fossil fuels as the discharge medium, as the storage medium, that could maybe outperform existing battery development by orders of magnitude. Liquid or gaseous fossil fuels as storing information could be a novel approach as well. But of course, I have to mention here that, to my knowledge, there are no examples of these ideas, maybe because they are unfeasible, unprofitable, or maybe the concept has not been thought and tried yet. I also add that processing hydrocarbon chains to novel materials such as graphene or stronger materials such as diamonds could also add value to fossil fuels or the carbon of those fossil fuels without having to burn them, without their combustion. And lastly, on the last part of my proposal, I talk here about how if we have to extract fossil fuels and if we have to burn them still, we should try to recapture all of the emissions that come from that combustion, both at the source of emission, which could be a factory chimney or an escape, an exhaust pipe, and also at the atmosphere. Here I talk about how it's my opinion that global emissions until 1990, the year I was born, were already enough to cause abrupt and catastrophic climate change. From 1990 until 2020, we have almost doubled the emissions from the period of the Industrial Revolution until 1990. This means that it's not enough to be carbon neutral now. We must capture back past emissions at the same time we reduce present ones. And the faster this is done, the better. Additionally, all the captured carbon must either be stored underground, protected from erosion and away from the biological degradation and respiration processes. This is because if organisms find that carbon underground, they might consume it, use it in their metabolic processes, and then release the exhaust, not the exhaust, the byproducts of their metabolism could be greenhouse gases that eventually go back to the atmosphere. Or we can create out of these captured carbon some sort of added value product which creates an incentive for institutions and individuals to store it and reuse it. And given the pressing time aspect of this part of the proposal, I think the measures should be the most radical. So here I talk about how it could be a good idea to deploy all available existing nuclear fission energy infrastructure to power mechanical carbon capture technology at the surface or near the surface, for example, on top of buildings, raised by balloons, etc. I also talk about how we could determine the geographical locations and altitudes which have marginally bigger concentrations of carbon. So if you can imagine in the atmosphere, it could be that our carbon emissions tend to concentrate on a certain narrow part of the atmosphere. So if we capture it there, we might get more of a bang for buck for our energy and time than if we try to capture the carbon in other places. And for this, we would need to deploy higher altitude capturing technology. Here also I talk about we need to reforestate en masse, but not just adding random plants and trees like it's very common to do. We have to ensure that the forest creates a biodiversity of other organisms, and to build the economic incentives so that there is an incentive for the people around to maintain the forest, either because you get, an added tourism to that specific forest or some other reason. But the idea here is that it's not just about the trees. All the organisms in a forest are made of carbon. So if you make a really biodiverse forest, you hold more organisms made of carbon, therefore you keep that carbon in the form of the organisms rather than in the atmosphere. So that's kind of to think about in this sense. It's not just the trees, because we like to think that the trees, okay, they're great because they suck the carbon out and they keep it there in some way, but it's all a whole web of animals and organisms and insects eating each other. As long as we prevent somewhat that carbon to go back into the atmosphere and we keep it in these, in the skin that the animals are made of, or in the birds or things like that, that's what I mean about increasing the density of carbon. Here I also talk about genetically engineering new rapid growth plant or algae for better carbon capture. And after we would have that plant or that algae capturing the carbon, we would then harvest it and store it, either to make a product that people would keep for a long time, or to just store it underground. So here an idea that I talk about is, for example, a highly durable byproduct that could not degrade easily could be, for example, concrete from algae. However, because we are talking about genetic engineering, here I mentioned that this new GMO should have DNA kill switches to prevent some sort of unforeseen second order consequence, such as, for example, we make some sort of new genetically engineered plant that is so good that it starts outcompeting with all the other plants that exist on Earth, and eventually it outcompetes the plants that we need to survive, like plants that we eat, and therefore we kind of kill ourselves in that way. And finally, I also talk about how it could be a good idea to precipitate CO2 into a hard and less reactive material. So you could set up artificial coral reefs in artificial lakes where certain water conditions could be adjusted or monitored, and then you would harvest these corals and you could use them as building materials. And also, at the same time, the resulting biodiversity of the lake would also ensure some sort of tourism revenue that could help maintain it. Another proposal would be to create calcium clouds, or this is to spray the calcium ions via aerial dispersion, and this would precipitate the carbon in the atmosphere into calcium carbonate, which could then fall back into the earth and we could harvest it. I do have one final note here on this proposal, which is that even with the big advances in nuclear fission, its waste and costs of handling will be a burden. However, I posit that the alternative of abrupt climate change is too costly. Therefore, it could be worth it for us to try to build as much nuclear fission plants as we can, even though we are in a way delaying another problem, which is how do we handle the waste from nuclear fission? What about any potential safety issues, some leaks in radiation, some maybe terrorist attacks that could happen from all these increased plants? So that's something to consider in my proposal. Also, I talk about how genetic engineering can be extremely dangerous if we don't do necessary long-term studies, and we should only really pursue it with DNA kill switches, if at all. And finally, I did not really consider geoengineering the climate directly, even though it can be a hot topic nowadays, because I think, it can have too many risks of potential extinction level from unintended consequences and interactions with the atmosphere, the geosphere, and the biosphere. So, I don't know, an idea could be that because we increase the reflectivity of the clouds on the Earth to make sure that more sunlight gets reflected back into space, we might accidentally make the planet way too cold even to support life, and in that way we might kill all life on Earth accidentally. It's just something so difficult to predict that I think we should just skip it for now. But yeah, there you have it. I will share this document in the description in case you want to read all the different resources I have here, because I have throughout the document some links. So I'm not really endorsing the links necessary or validating the companies and products or patented processes that are mentioned. I'm just like using them as an example. When I talk about, I don't know, concrete algae, I have a link for that. When I talk about how geoengineering could have a risk, I have a link for that. So if you are interested, you can read the document below the description. But yeah, thank you for watching. I hope maybe this gave you some ideas just to think about the concept of climate change in general. Or maybe if you're planning on starting an idea, a product, a service, who knows, maybe you'll get inspired by this. So yeah, thank you for watching, and I'll see you in the next video.